Okay, let me get my screen shared here really quickly. All righty. So thank you for coming today. So this is a discussion on the new cloud system for Data Harmony. Oops. So what is the purpose of Data Harmony Cloud? As our clients' data needs have been growing consistently over the past few years, we've had more and more occurrences of millions of documents needing to be processed in a matter of days. And Data Harmony has needed to be able to scale with this. And how are we going to approach that problem? Well, it requires really a two-step process, and that's a scalability of the server itself, the Data Harmony platform, as well as an optimization of our workflows internally. And we achieve this through a centralization of our project management, which is a Git-driven project storage and version control for your thesauri and rule bases, utilizing Docker containers for ease of deployment and project loading, as well as Kubernetes clusters for highly scalable and self-managing clusters that are capable of mostly self-administration. The centralized Git project store is a re-envisioning of how we manage, version, update, and deploy projects. And utilizing Git-style repositories for those project storages and versioning, we can use Bitbucket, GitHub, or any of the other Git-like repositories. And what are the benefits of this approach? Well, it allows for project development to be more agile. So we can implement new Thesaurus features or terms in sprints without affecting our production thesauri anymore. And development versions of that thesaurus can be deployed for testing before being deployed to production. And when ready, all we have to do is push the development version of the project to our production environment, and we're ready to go. And the other advantage of this is on the project management side, where that's greatly simplified at all levels due to native integration with Jira, Trello, and a variety of other project management utilities. Docker containers are the approach that we've taken to simplify the deployment of server instances and our clusters. So Data Harmony is needed to scale alongside our client's infrastructure. So now we're implementing Data Harmony more as a platform as a service alongside our software as a service offerings. So the amount of data that can be processed scales at a dramatic pace with our clients' needs. So our cloud implementation allows us to scale alongside our customers seamlessly through these Docker containers. It also allows for development around Data Harmony to be streamlined and integrated also with agile practices, because these resources are available as needed rather than having to be deployed and gone through DevOps or some other complicated deployment process. And this way we can also create production and staging environments when we're updating server versions or implementing our thesauri changes. And this has historically been an area of hiccups for the deployment of our services, and this eliminates that. We can quickly deploy staging environments to make sure everything is working as we expect before we roll over to new versions. So what are Docker containers? Just to give everybody a little bit of a primer so we're all on the same page. An image, that's the basis of the Docker container. That's the operating system, all of our server code, everything that we could potentially want. What is the container? That's where the image is running in. You can think of it as a virtual machine. So you have your virtual PC, it's running that operating system. What is the engine? Well, that's the software that executes commands. In this case, that would be Data Harmony. That would be our service that's running as the engine on this platform. What is our registry? Well, this is what allows us to store different copies of versions of Data Harmony, as well as where the repos for projects get pulled down for our clients or our internal use for quick deployment of resources. And what is our control plane? In case like a Kubernetes cluster or however we're deploying complex infrastructure. What about Kubernetes? Well, Kubernetes are an open source system for automatic deployment and automatic scaling and self-managing containerized applications. What does this do for us? It improves reliability first and foremost. By continuously monitoring and managing our containers, they will scale alongside of our application and handle changes in load. We now can have better use of our infrastructure resources. It helps reduce those infrastructure requirements by gracefully scaling up or down, depending on how traffic is changing, without having to deploy significant dedicated resources. It coordinates with containers that run across our entire system. So it ensures that they're running correctly, that they're running well, and if new additional resources need to be spun up, it handles that automatically. And it also allows us, and most importantly, to easily coordinate the deployment of our systems. Which containers and projects need to be launched? Where should they be launched? Whether that's on our servers, your internal cloud, AWS, Azure, wherever is equally the same. So how a Kubernetes functions effectively is that we have the Kubernetes master that governs a pod. That pod can hold one copy or several copies of the server. And all we have to do is simply type a command line that runs on service boot, and we have a fully functioning service. As our production environment grows, as our environment needs to scale up, that's handled automatically by the Kubernetes master, which makes it where effectively it's a self-governing, self-managing system, eliminating the potential for human error in these deployments. How does this benefit you? Well, deployment workflows, deploying, upgrading, and maintaining our project versions, our server environments, and our production workflows. It centralizes our projects into Bitbucket or any other Git repo, so we have easier deployment and versioning and deployment of those projects. We can also port projects, whether it's to production, to development environments, or entirely different apps. It allows us to take the agile platform development approach because we can have on-demand production environments while also relying on self-managing services with scaling logic that we've already provided. There's no need for anyone to worry about how should Data Harmony be scaling. We have already provided that logic. And finally, it increases the maximum scalability of Data Harmony. And that cloud stability can come from, once again, AWS, Azure, Google, or on-premises clouds. So how does this deployment workflow work? Well, the most important change is that we have seamless serverless deployments and upgrades now. Server upgrades are facilitated through the Docker service, which reduces or eliminates any need for downtime. Classically, as we've known, we would tell you your service will be down for, say, 30 to 45 minutes. Now we're looking at a few seconds. But in those few seconds, there is no longer a downtime for your service because the seamless transition from the old version of the service to the new service of the version happens automatically through the Docker containers. Project migration is handled automatically through the containers logic as well. All server and project relationships are managed through API keys now. Those API keys that you feed to the container know which projects are related to the server and will automatically pull them down from Bitbucket, start them for you, and the server is ready to go. Utilizing Docker to automate the deployment process reduces deployment time. As we just talked about, we're talking about a few seconds now for new services rather than half an hour to an hour. And maintaining the service is handled automatically through the container logic. So if we have a Data Harmony instance that has gone sour, it will automatically repair itself by spinning up a new instance of the container. What about deployment workflows? Well, projects are now maintained through centralized repositories. Once again, this can be Bitbucket, GitHub, or GitLab, or any of the other Git-like repositories. This simplifies how projects are stored and tracked, whether that's in-house or your own personal projects. And those Data Harmony projects being centralized in-house for us in Bitbucket makes deploying projects through Docker extremely easy. Once again, it's based on the API key. And this process is entirely automated now. And for new pipelines, workflows, or applications, a single command line allows for immediate deployment. And after that one time of writing that command line, the system will automatically handle it from there. And projects are now strictly versioned and branched, allowing for app-dependent versions of the thesauri. So if we have a need for different versions of our thesaurus over in our tagging versus how we would want to be able to search them, for example, we can maintain that through these version thesauri. How is your project deployed? Well, it's a simplified and efficient deployment and update of your service. So implementing Bitbucket allows us ultimately to version control all of this. So this allows us to implement a proper development to production workflow process, where as we make changes to the thesaurus, until we're ready to have this in our production environment, it simply goes to our development branch, where once it's ready to be merged into our production environment, it simply just sits there and waits. So centralizing the projects in this way alleviates the following issues. We no longer have to clone projects to maintain a development copy. When all changes are finished, the changes can then be merged and pushed to production. And the production version of the project on Bitbucket can be seamlessly pushed to those containers. This also ultimately allows us in-house and for our customers to have agile platform development by on-demand production environments. So project deployment, upgrading, or migration is now simplified to allow for swift platform changes. This means that DevOps, IT, and management have complete control over Data Harmony services and how they're deployed and what resources they're allowed to use. And once again, this allows for that agile platform deployment, and infrastructure planning is now minimized due to the automated nature of these resources. And staging environments for updates. Development teams have access to deploy identical or development versions of their Data Harmony stack. And moving from staging to live is also streamlined once the system is deemed ready for production. And once again, probably the most important component of this is the self-managing nature of the service. Utilizing built-in monitoring tools in our container, the Kubernetes cluster or container can self-govern and heal itself. With little to no intervention from our DevOps, the Data Harmony service is capable of monitoring itself and taking steps to prevent any service interruptions. And the logic for governing these behaviors is provided by us. In the case of disaster or on any infrastructure, on reboot of the server, the Docker service will restore all known containers of Data Harmony currently running. And downtime is significantly reduced. If our Mars server were to go offline, we would be looking at a day to a day and a half to get all of our instances back up and running and tested. Now we're looking at a few minutes as being the worst case scenario for our services. And the final and probably most important component of this is the scalability of Data Harmony as a platform now. Whether your use case is to use on-premises hardware, lease hardware, or deploy in the cloud, Data Harmony is platform agnostic and can be deployed in any of these services, but can scale to whatever need you need it to have. Whether we're looking at 200,000 records or 20 million records that we want to process in 2 weeks, 8 days, whatever our goal is, we can now scale the service to meet those needs. And they can functionally be scaled to infinitely many resources. Effectively, whatever AWS can provide or your on-premises cloud can provide, we can scale to those resources. Meanwhile, while the Kubernetes cluster or the Docker container handles the day-to-day management of the service. We're monitoring rollovers and automatic container deployment depending on your current system load. So when will this be ready? Data Harmony Cloud is available now. We can start deploying using Kubernetes clusters or moving your projects over to centralized Git management and handle these kind of versionings and automatic deployments. How can we try it out? Just ask. We'd be happy to run some experiments. Now, how complex is this to work with? For most people, just a command line. It takes 10 seconds to spin up. And I think I wanted to move a little quicker because I knew we were running a little bit behind on time. So now I'll open the floor to some questions, and I think we already have one from Margie. Is this all behind the scenes in 3.15? Yes, it is. All of this is ran behind the scenes. You don't need to worry about, oh my gosh, how do I get into my development version of my project? That's handled for you. The only time you need to worry about that is when you're wanting to push from development to your production, which is just a button. In the save feature, the new save feature for Data Harmony, you can move immediately from your development environment to your production environment at the press of a button. Is there something else I need to do on the customer side to use all of this other than upgrade to 3.15? Absolutely not. This is all handled automatically for our current customers. What this is ultimately meant to do is increase the overall service stability and ensure that there are no prolonged downtimes and that the service is reliable, reachable, and scalable.